Every pencil you have ever picked up contains a material that was once so rare and valuable it was placed under armed guard by the English crown. The humble pencil has one of the strangest origin stories in the history of everyday objects. For most of human history, writing was expensive, slow, and permanent. Scribes worked with quill pens and ink that could not be undone. Artists used silver point, a fine silver rod dragged across specially coated paper, delicate, costly, and impossible to erase. Chalk and charcoal sticks had been used for drawing since prehistoric times, but they smudged catastrophically and could not hold a fine line. The world was filling with ideas that needed to be written, sketched, calculated, and revised. Then, in 1565, in a remote valley in the north of England called Borrowdale, in what is now the Lake District, a violent storm toppled a large tree. Beneath that uprooted tree's roots, local farmers discovered a strange, heavy, gleaming black mineral. It was slick to the touch. It stained their fingers dark gray, and it left a startlingly clear, dark mark on whatever surface it touched. The farmers assumed it was a form of coal, but when they tried to burn it, nothing happened. It would not ignite. It crumbled easily, but it would not burn. This was something else entirely. The shepherds of Borrowdale quickly found a practical use. They began rubbing chunks of this black mineral across the wool of their sheep to mark which animals belonged to which farmer. It was perfect, clear, durable, and easy to apply. Word of the material traveled quickly. Artists, merchants, and scholars arrived in Borrowdale to see it for themselves. Here was something that could draw a flawless dark line and, crucially, could be removed from paper far more easily than ink. What made Borrowdale extraordinary was the purity of the deposit. The graphite found there was almost 100% pure, in solid, cuttable lumps. Nothing like it had ever been found anywhere else in the world, before or since. No one yet knew what this mineral actually was. It looked like lead, it was heavy like lead, and it left a gray mark like a lead stylus. So they called it black lead, or by its Latin name, plumbago. It was not lead at all. It would take more than 2 centuries before scientists understood that the material was a form of pure carbon, the same element found in diamonds, just arranged very differently. The name graphite was not assigned until 1789, when a German geologist named Abraham Gottlob Werner named it from the Greek word graphene, meaning to write. The name was right, even if it arrived late. The very first pencil-like instruments were simply chunks of Borrowdale graphite cut roughly into sticks and wrapped in string or sheepskin, to keep the user's hands clean while they worked. In 1565, the same year as the discovery, the Swiss naturalist Conrad Gessner became the first person to describe in print a writing instrument made of a graphite rod held within a wooden handle. It is the earliest known description of what we would recognize as a pencil. That wooden handle was the decisive innovation. Craftsmen began carving a groove down the center of a stick of wood, laying in a thin rod of graphite and gluing a second plank of wood on top. The pencil had found its form. The word pencil comes from the Latin pensillus, meaning little tail, originally the name for a fine hair-tipped artist's brush. The graphite stick borrowed its name from the very instrument it was beginning to replace. The Borrowdale deposit was so valuable that the English crown moved to control it. Soldiers were stationed at the mine. Output was rationed and taxed. Unauthorized extraction was treated as a serious crime. A black market emerged almost immediately. Smugglers bribed guards, hid graphite inside clothing, and sold it to buyers across Europe at enormous markups. Borrowdale graphite was, for a time, among the most tightly controlled substances in England. Meanwhile, craftsmen in the German city of Nuremberg had obtained samples of Borrowdale graphite and were studying how to manufacture pencils at scale. They had a problem. The graphite available to them was often inferior and too crumbly to hold a shape. To work with impure graphite, Nuremberg craftsmen began grinding it down, mixing it with binders like sulfur and antimony, then pressing the paste into rods. The rods were not as fine as pure Borrowdale sticks, but they were workable, and Nuremberg could make them by the thousands. By the early 1600s, Nuremberg had become the pencil capital of Europe. An entire ecosystem had formed around the trade. Graphite grinders, woodcutters, casing makers, polishers, and merchants, all devoted to a single slender product. In 1761, a cabinet maker named Caspar Faber opened a small pencil workshop in Stein, just outside Nuremberg. He could not have known he was founding a company that would still be in business more than 260 years later. That company grew into Faber-Castell, today one of the largest pencil and stationery manufacturers on Earth, still headquartered near Nuremberg, still run by members of the founding family. Across the Atlantic, the American colonies relied entirely on pencils imported from England and Germany. After independence, that supply became unreliable. The new nation needed to learn to make its own. In 1812, a Massachusetts cabinet maker named William Monroe handcrafted what are widely credited as the first American-made wood-cased pencils. They were unrefined by European standards, but they existed, and America had a starting point. In Concord, Massachusetts, a family named Thoreau ran a small pencil-making business. The father, John Thoreau, was the manufacturer. His son Henry David, the same man who would later write Walden, worked in the factory. Henry Thoreau brought rigorous study to the problem of pencil quality. He researched grinding and mixing techniques and reportedly improved the formula significantly, until Thoreau pencils were considered among the finest in America, rivaling European imports. But the most consequential leap forward in pencil technology did not come from England, Germany, or America. It came from France, and it came from war. When the French Revolution erupted in 1789 and France went to war with much of Europe, Britain and France became enemies. Britain controlled Borrowdale. France was cut off from the world's only known supply of high-quality solid graphite. French armies, engineers, architects, and artists all depended on pencils. Napoleon Bonaparte reportedly kept one in his pocket at all times, and France, cut off from Borrowdale, had no reliable way to make them properly. The man brought in to solve the problem was Nicolas Jacques Conté, a painter, balloonist, military officer, and inventor, described by colleagues as someone who could accomplish anything with his hands. In 1794, Conté was tasked with producing high-quality pencils from France's own inferior, impure domestic graphite. He had months, not years, to deliver a working answer. Conté's breakthrough began with an insight that seems obvious in hindsight. Instead of cutting graphite in its raw, lumpy form, he would grind it into a fine, consistent powder, and then reconstitute it in a controlled, designed form. He mixed the graphite powder with fine clay, added water to form a smooth paste, pressed it into thin rods using molds, and placed those rods into a kiln to be fired at high heat. When the rods emerged from the kiln, they were strong, smooth, and consistent. They held their shape. They sharpened cleanly. They left a reliably dark line on paper. Conté had essentially invented the modern pencil core. But here was the deeper insight. By changing the ratio of clay to graphite before firing, Conté could precisely control how hard or soft the resulting rod would be. This single variable opened up an entire spectrum of pencil types. More clay produced a harder rod, one that held a fine point and left a lighter, sharper line, ideal for technical drafting. More graphite produced a softer rod, richer in tone, ideal for drawing and shading. Conté filed his patent in 1795. The process he invented: grinding graphite to powder, mixing it with clay, pressing it into rods, firing it in a kiln, is, with refinements, the same process used to make every pencil in the world today. Conté's process gave rise to the grading system still stamped on every pencil. H for hard, B for black, meaning soft. The letters indicate where a pencil falls on the spectrum between light, precise lines and dark, expressive marks. The modern range runs from 9H, almost as hard as stone, used for fine technical drafting, to 9B, so soft it smears at the lightest touch, beloved by portrait artists for deep tonal shadow. The everyday writing pencil sits at HB, right in the middle. Conté's process had solved how to make the pencil, but one very ancient problem remained. What do you do when you make a mistake? For most of human history, people erased pencil marks with bread, specifically the soft white inner crumb, which was absorbent enough to lift graphite particles cleanly from the surface of paper. It worked after a fashion. Writers and artists kept a fresh loaf at their workspace not only to eat, but to correct their errors. Bread went stale, bread mold, and attracted insects. It was a solution that reliably created its own problems. Then, in 1770, the English chemist Joseph Priestley noticed something remarkable about a lump of hardened material that had reached Europe from South America. The material was natural rubber, dried sap from a tropical tree. Priestley observed, almost as a footnote in his writing, that a small piece of it would cleanly rub graphite marks from paper. He called it a very good rubber. That casual observation gave us the word rubber. Before it caught on, English speakers called the substance caoutchouc, borrowed from an indigenous South American word for the tree from which it came. Priestley's term proved more durable. For nearly 90 years after Priestley's observation, rubber erasers and pencils were sold as entirely separate objects. The idea of combining them seems obvious in hindsight, but no one patented the combination until 1858. In that year, a Philadelphia stationer named Hyman Lipman attached a small plug of rubber to the flat end of a pencil, set into a recessed groove, and filed for a patent. The idea was simple. The timing was right. He made a fortune. Lipman sold his patent a few years later for $100,000, an extraordinary sum in that era. The buyer, a man named Joseph Reckendorfer, attempted to enforce the patent against pencil manufacturers across America. In 1875, the United States Supreme Court struck down the patent. Combining two existing objects, the court ruled, does not constitute a new invention if each part still performs only its original function. The patent died. The design survived. The eraser-tipped pencil spread throughout the American market and eventually the world. Today, in the United States, the phrase "a pencil" almost always means one with a pink eraser at the end. Consider the shape. A pencil is a hexagon, 6 flat faces arranged around a central core. Why 6? Why not round? Many early pencils were round, and they rolled. Off desks, off drawing tables, off the narrow ledges of ship cabins. They fell, they broke, they vanished under furniture. Designers looked for a solution. The answer was 6 sides. A hexagonal shape will not roll on a flat surface. Place it on an angled desk and it stays put. The geometry is simple. The physics are reliable. The problem disappears. There is a secondary benefit. When you grip a hexagonal pencil in a standard writing hold, 3 of its 6 faces naturally press against your 3 gripping fingers: thumb, index, and middle. The shape fits the hand without any conscious adjustment. By the early 1900s, the hexagonal pencil had become the standard for everyday writing instruments worldwide. Specialist pencils kept other forms for other reasons, but for general use, the hexagon had won. A carpenter's pencil is flat and oblong. Because a roofer or framer needs a pencil that will not roll off a sloped surface, even in a stiff wind. Different work, different geometry. Form follows function even in the most ordinary object. Here's a question most people have carried for years without ever thinking to ask. Why are pencils yellow, not graphite gray, not the color of bare wood? Yellow. For most of the pencil's history, pencils were not yellow. They were sold in their natural wood color, or painted red, black, green, or whatever a maker preferred. Yellow was simply one option among many. By the 1880s, the Borrowdale deposit was largely exhausted. Mined for over 300 years, it could no longer supply the world. The finest graphite was now coming from deposits in China and from Siberian mines exporting their product through Chinese trade routes. In the Western imagination of that era, yellow was strongly associated with China, the color of the Chinese imperial house, of silk, of a distant and prestigious civilization. Pencil manufacturers who wanted to signal premium Eastern graphite began painting their pencils yellow. In 1889, the Austrian pencil company L&C Hardtmuth launched a luxury pencil at the Paris World's Fair. They named it Koh-i-Noor, after the famous diamond, and they chose a rich, striking golden yellow as its signature color. The Koh-i-Noor's success did not go unnoticed by American manufacturers. Painting a pencil yellow was a signal, premium graphite, a claim to quality, an air of the exotic. American companies adopted the convention rapidly. Within a generation, yellow had become so strongly associated with pencils that it stopped being a quality signal and became simply the expected norm. The original meaning dissolved. The color remained. By some estimates, more than 3/4 of pencils sold in the United States today are yellow, not because of Chinese graphite, not because of any quality advantage, but simply because that is what people expect a pencil to look like. Inside a modern pencil factory, Conte's process runs on industrial rails. Graphite powder and clay are blended in precise ratios, pressed into rods, fired in kilns, and then sandwiched between two grooved planks of cedar wood, glued, compressed, and sliced into individual pencils. For most of the 20th century, the preferred casing wood was incense cedar from California, prized for how cleanly it sharpens without splintering. As California cedar grew scarce, manufacturers shifted to pine, basswood, and sustainably sourced cedar from other regions. By some estimates, between 14 and 20 billion pencils are produced worldwide every single year, in factories across China, India, Germany, Brazil, and the United States. Each one contains a core made by the process Nicolas Jacques Conte invented during a wartime emergency in 1795. A core fired in a kiln, a process that has not fundamentally changed in more than 200 years. A single standard pencil can draw a continuous line roughly 45 miles long, or write somewhere in the region of 35,000 words, before the core is fully worn away. Most pencils are discarded with miles of line still left in them. Every pencil you pick up is the product of a storm in Cumbria in 1565, a French officer's wartime ingenuity in 1795, a Philadelphia stationer's small inspiration in 1858, and a marketing decision made at a Paris World's Fair. No single person invented the pencil. It was assembled over roughly 450 years by sheep farmers, German craftsmen, French engineers, American cabinet makers, chemists, stationery traders, and designers who wanted to stop things rolling off desks. That is the thing about ordinary objects. They carry more human ingenuity, more accidental discovery, more patient problem-solving than almost anything we would choose to call remarkable. Somewhere in your home right now there is almost certainly a pencil. A graphite core fired in a kiln, cased in cedar, tipped with rubber, painted yellow, cut to a hexagon. 4 centuries of civilization, small enough to lose behind a sofa cushion. Every ordinary thing was once extraordinary. Every familiar object has a story this layered. That is why we are here. This is Origins. Subscribe and come back tomorrow. There's a new origin every single morning.